Hello and welcome to the next episode of Digital Twin Podcast. Today we will talk about three most important technologies regarding to Industry 4.0. Stay tuned. Digital Twin Podcast is a place where technology and business is going hand in hand.
If you are thinking about digitalizing your company, you found the right place.
Podcast is hosted by Adrian Stelmach, consultant who implements IT solutions for manufacturing companies.
And Paul Pachowicz, industrial digitalization expert, who helps global companies to optimize production processes. Okay, three most important technologies. Let's figure out if we are thinking about the same ones or you're thinking different ones. I think IoT devices would be the number one technology because it allows us to gather data. What about you?
Because there's, of course, it's debatable what three most important technologies we could consider regarding to to different sectors, let's say, or different businesses and different people. But if you think about how much of us, what every human beings in developed countries uses in every single day, I would say that most of us use, for example, one of those three will be definitely IoT.
Mm-hmm. And then I just wanted to do like a quick peek of technologies, because we also have to do like a summary of the previous episode, I guess, right? So I just wanted to know your number one, and then we'll go back and we talk about number two and number three. But maybe we can, summarize the previous episode first, and then dive into those three different technologies.
Sure.
Do you want to do it, or?
I can do it, no problem.
Do you want to summarize the previous episode, or? No, I just think that just it allows us to, have this story going, so it's not like it's different episodes, but they are somehow, connected to each other.
Yeah, so, we are still in a series of industrial revolutions, and probably the series maybe we'll go for another few episodes right away, or maybe we'll pause for something else, we will see. But in general, in the last episode, we mostly focus on a broader aspect and broader context for industrial 4.0 implementations. We talk about education, about legislation, and about how exactly we as human beings, as average human beings, we are ready regarding to our capabilities, our knowledge to implement and adopt some technologies. And today we want to talk more deeply about the three most important ones, which we think most of us statistically have in common in our daily lives.
Yeah. Okay. Beautiful. So we do agree that IoT is the main one. Let's say not the most important one, but the main one that allows us to collect data, draw conclusions, but also allows us for the IoT devices to talk to each other, right? Sorry. No, I just wanted to know if we should explain what IoT is, because we kind of, just because we work in that space that we know, but I think it would be important to kind of explain it in the most simple way possible.
Yeah, sure. So in general, IoT means Internet of Things, and as it says, it means that there are a lot of things which are connected to internet. So if there's a thing which you can connect to internet, it has IoT capabilities. And what are those things? It could be anything. Mainly, it could be your toaster. It could be a thermostat. It could be like a sensor of humidity, which you have in your house. It could be, for example, your garage door opener. if you have automated door opener in your garage. It could be mainly anything which you can remotely, control
Operate.
with internet. Yeah. And what I also want to explain is the difference, because I looked when I talk to people, sometimes people mislead IoT devices with just standard sensors. Because like 50 years ago, we also have temperature sensors and stuff like that. It's not something new. But they're IoT temperature sensors, let's say. There is like two big differences if you compare it to standard sensors. So first of all, let's say let's make an example. Let's say like 20 years ago, you decided that you want to have a smart home. Okay, so there's no IoT devices. You just want to have a smart home which you can control with your phone or with your computer, because you don't have a smartphone yet. So let's say you want to do it, and how you will do it. You will do it the way that most of the manufacturing companies were doing it like 20 years ago. So you are just putting a lot of different sensors, like temperature sensors, like for example, automated door opener, engine and stuff like that. You will wire all of it to the central PLC. So you will just use the same PLC as the machines in manufacturing. And then you'll connect this PLC to some kind of a SCADA system, which you also have to develop in your home only for your purposes. And then if you already have internet, let's say you have to connect to this SCADA remotely and just have this super smart home. So as you can imagine, it's very complicated and costs a lot of money, because probably the system costs the same amount of money than building your home. So not a lot of people can afford it back then. And yeah, this is how does it work. Nowadays, you can just buy an IoT device in your local shop, which costs like $20 or $10. Like, let's say it could be for socket engine controller or temperature controller, whatever you want. You connect it, you configure it, the Wi-Fi, and that's it. Because you already have probably an app which you can deal with all of those sensors. So first big difference is that you don't need to have like a central controller or anything like that, because you can connect the sensor directly to the internet. Of course, it's not, someone can say, okay, we have an issue with security, because someone can just look at my temperature or whatever at my home via internet. Of course, it's an issue, but we will talk about cybersecurity maybe later on. So this is the main difference, the first main difference.
But also that the temperature at your home is maybe not super sensitive data, right? Maybe
Yeah.
Even if somebody's looking at it, let them look at it or something.
Yeah, but opening the garage door or just turning off the cameras, yeah, it could be a pretty sensitive one.
Yeah, and all the people that can take advantage of it, they know. They most likely know how to breach that.
Yeah. Okay, and the second one, because I want to say also about the second one. So the first one is that we are, doing the same thing, but much more cheaper and much more easier, right? Mm-hmm. So those devices are directly connected to the internet. And the second big difference is that those IoT sensors, they have a lot of more different options than a standard, let's say, temperature sensor. For example, if you have an IoT temperature sensor, he is not only measuring temperature, but he can also have some diagnostic information. Let's say that he will inform you if there's something going on with it, or he will inform you if the temperature is too high than normally it should be. And also he have capabilities for communication not only with you via some application and so on, but also he can connect to other sensors to direct some information. And this an example of how does it work is, for example, if you have Amazon, Echo or Siri at home, like some kind of device which you can communicate with, and those devices are communicating to this main device, which is mainly talking to you, and you can have everything connected to one internal network. So those are two big differences between IoT devices and standard sensors.
Okay. Yeah, I think the explanation of okay, but some people are wearing Apple Watch. I'm pretty sure you're wearing an Apple Watch.
Yeah.
Is it an IoT device or just a sensor?
Yeah, Apple Watch is an example of a lot of, you can say, IoT devices which are combined in one device, because in general it could be connected to the internet. Apple Watch is an example of IoT, let's say sensor, but not only sensor, because there's also control capabilities and so on.
Yeah, but okay. I just wonder if Apple Watches can talk to each other, and that would be like they cannot, right? They can. There are other IoT devices that Apple Watch can like talk to, or not so much, or it only connects to internet and then.
Yeah, for example, Apple Watch or a lot of different, smart watches have a capability to, let's say, call emergency if they see that something's wrong with you. So let's say you have a heart stroke or heart attack or stroke or whatever you have, which can be measured by this watch. It could just directly, inform emergency numbers and stuff like that. Other thing which is capable for is you can, for example, see your smart home, different sensors from your watch, and you can control it. So yeah, there's a lot of different capabilities. You also mentioned in the last episode about Aura Ring, right? So Aura Ring is also an example of IoT device, let's say, or IoT sensor, because you have it on your finger. It measures all of the information regarding to your pulse and so on. Somehow he also knows how is the quality of your sleep, and and it gathers it and sends it to some cloud when you have access, and you can analyze it and you can draw some conclusions. So yeah, we're not aware how many IoT devices there are surrounding us.
Sure. And then so that's, I think, like a summary of the first one, which is the IoT device. I think it's more understandable now. I'm sure there still could be confusion, between sensors and IoT devices. But let's move to the next one and talk about artificial intelligence. This is scary for some, or beneficial for some other ones. And I would really like to understand your definition of artificial intelligence, because you work with technology much more than an average Joe, and we sometimes make fun of this air conditioning, being able to use AI for what we don't really know, but it's there. So I would really like to know your definition of artificial intelligence from like technological, with your technological background in place.
Yeah, so because I don't like specific book definitions, but if you ask me what artificial intelligence in general is, I would say this is a general term from technologies that allow computers to learn something from a specific data. Learn and conclude. Okay? So let's say let's make some examples. We are making fun of sometimes things because AI nowadays become like a buzzword, you know. People are using terms, oh, we have something with AI and this is way better, way different. I would say, you know, it's not necessarily that you have to put AI everywhere. It will be better every time. I'll give you an example. Let's say you're changing your desktop on your laptop or your phone. Let's say you are changing it once in a year, right? So if you want to change your, you know, laptop desktop wallpaper, what you do? You're using probably your right mouse button. You'll choose change my desktop. You'll find the wallpaper you like. You will choose it. You'll click OK, and that's it, right? And your computer doesn't need to have artificial intelligence to change your background, because this is your interactions are being processed by specific algorithms on your computer. So your computer knows what means that you're clicking your right button, your right mouse button. He knows what he should do to help you find your wallpaper, and he knows what he should do after you find the right one, and you'll click OK, right? You don't need artificial intelligence for that. And now let's consider an example where is artificial intelligence used for this, like a simple, example. So artificial intelligence, what it can do, it can learn. Let's say it was on your computer. He's analyzing data from past 10 years, and it analyzes the way you behave and the way your previous behaviors of changing your desktop looked like, and the next one he will do it for you by the amount of information and data gathered from the previous situations, right? So in short term, you can say that artificial intelligence will change your desktop for you by learning from your previous changing desktops experiences. Okay, and this is very simple, just example to make it understandable. And let's just sum up this example. So is it really necessary to use artificial intelligence for that? Probably not, because if you do it once in a year, if you spend like 2 minutes on it, probably it will be not good to implement like a software for that. But let's consider other example right now. Let's say you are working as a e-commerce manager for Amazon, Allegro, or eBay, or another giant website, e-commerce website, and you have millions of information gathered in your database, right? You have millions of information related with your customers, with their experience, with the way why they, for example, drop some baskets, how they behave, and so on and so on. Every one of us have some, in all of the interactions which we do in our daily lives, we help them to gather this data. And now how we can manage this kind of amount of information correctly, right? It's very hard. Probably, of course, you have some algorithms which are comparing different ways human behave online and so on, and they will help you conclude. But in every single day, those behaviors can change, and it's problematic because you have to create new algorithms and so on. And artificial intelligence in that way can just learn from the way behaviors change, and it can just give you every time actual information and tell you exactly what to do. For example, to optimize the way your website works, to optimize your user experience work on your website, your pricing, how does it work, where you should drop prices, when you should get it higher, and so on. So, and this is a lot of sense to make artificial intelligence on wheels in this case.
Okay, I don't think anything else needs to be added here for the AI part. As you walk us through, yeah, your perspective of AI, which I believe is a little different than most people when they ask ChatGPT for some answers. So yeah, this is a little more advanced version of what AI actually is. And then the third part, the third element that we'll be discussing today, it's cloud computing, um, and then how we can talk about it in a way so we can show the difference between cloud and cloud computing. I think that
Hmm.
that also needs to be established at the beginning, and then we can talk more about cloud computing.
Yeah, sure. Yeah, one thing which I want to add also to artificial intelligence, or maybe two.
Mm-hmm.
So, first one will be that we will have specific episodes for artificial intelligence because I think there's much more to talk about. But
Mm-hmm.
what I want to add is that there's a lot of things which is using artificial intelligence. We are not even knowing about it. Just giving you this e-commerce example. But ChatGPT is revolutionized because they figured out how to actually, talk to people, so anyone can use it. So this is like a game changer.
Mm-hmm.
Uh, and also, yeah, so corresponding to cloud computing, I would say that artificial intelligence, for example, uses a lot of cloud computing. I mean, you don't need cloud computing or any kind of cloud to run artificial intelligence, but more data you have, more computing power you just need, right? So it's you can just implement an algorithm, artificial intelligence software on your computer, and he can use your power, but your capabilities, counting capabilities, probably will end like in a few minutes, and so on. And that's why a lot of those kind of stuff is going on in via cloud. And what cloud is, in few words, you can say that you can outsource the way data is stored, or the data the computing, the concluding process is managed, right? So
Mm-hmm.
there's a different kind of clouds, you can say. We can have a software as a service, right? This is also a cloud. An example, Netflix, HBO, or any kind of AI software which you're using nowadays. You can have a platform as a service, right? So you're outsourcing the entire, let's say, infrastructure. Um, Platform means that you are using a specific place in internet which you can build your own, let's say, solution, right? So let's
Mm-hmm.
say you are starting a company, you need a lot of computing power, so you can buy physical servers and install software there and so on, or you can just um, hire, or just buy some specific space in the cloud, some in servers, because it is on server, but it's not server in your location. It could be server in US or China or whatever you want, but just a small amount of the server, which is much more than you actually need. uh, it could be also the entire infrastructure you can build in the cloud. You can use it for storing files, and we know Google Drive, Dropbox, and so on. It works like that. You can also use it for any kind of VODs. Use cloud right now. Websites are built on cloud, right? It's not like you are typing www Google and it means that Google is been installed on your computer. It's just somewhere in the cloud, in the website, right? In the web. So nowadays, most of things are in the cloud, and we are using this just on demand nowadays.
Okay. Nothing to add here, I guess, because you give us those explanations um, that are pretty accurate, and also they describe it in a way that there's nothing to add. So, but let's say that we have this, all those technologies that we're using, cloud computing, that we're using IoT devices, and artificial intelligence, of course. There's basically data that we transfer, send to each other. The devices are communicating. We are storing some data in the cloud, right? Then we analyze the data through cloud computing. There is so much data that now becomes accessible. If people, the people that are trying to, breach those security gates, there's more and more data available. So the more and more data processed. So that means there's more and more possibility for, cyber criminalists. I don't know how you call them, but for those people to try to access your data. And that brings us to like another point. Okay, we have all that technology available and we are using all that technology, but that the data that we are collecting and analyzing are exposing us to danger, right? And then maybe this is the time to talk about cybersecurity.
Yeah, sure. I want to add also why we choose those three, because if you combine it together, artificial intelligence needs data, and the IoT devices can give you this data. This information data have to be gathered somewhere. It could be gathered in some kind of a cloud, and also you can use cloud computing to actually make work, the artificial intelligence make the work. The weak ones, let's say, right? So that's why we gathered those three, because nowadays all of us, we even don't know how many times we are just experiencing combination of those three. And of course, as you said, there is a security issue, because as you can imagine, a lot of data which we have, which we gather with us, they are very sensible. Some of them are related with our privacy, and some of them are, even related with national security. You can imagine if you lose control over a drone which is flying somewhere and could destroy some building and so on, or like atomic, like energy plant, which can just you can choose the parameters and so on. So it is scary, but regarding to development of those technologies, also we have a way different capabilities to make it secured, and I think because in manufacturing, as I see, there's a lot of examples that people still don't use cloud because of the security issue, right? So they just invest much more money that they maybe could, if they use cloud, to have to make sure that all of this information and all of the possibilities to control, for example, remotely the plant, the machines, and so on, are locally in local infrastructure. But the way this approach change is because in every single day the cloud is just much cheaper option, right? And also it's much more flexible to just set it up or to just manage it. So I think it's just a matter of time when we switch more to cloud. But also what you have to talk about regarding and then more people will switch to cloud, more security probably have to be more we have to invest in security, but I think it's hard to tell you exactly how to solve this problem, because it is specific to a specific implementation or application which we consider, but it is an issue for sure.
Yeah, and then a quick question: why is cloud getting cheaper?
Yeah, you know, it's a good question. Let's say you can imagine yourself like, let's say, 15 years ago or 20 years ago when you had those floppy disks, right? Those floppy disks which had like 1.5 megabytes of data, so you can just put few documents there and that's it. And this floppy disk costs how much? Like $5, $2. In the beginning it was probably 20, 30, right? So it was pretty expensive. Nowadays you're buying just 2 terabytes of data in the cloud for, you know, for how much? Like $10 per month or something like that. So we can just show the curve of how gathering data was in the time getting cheaper. But in general, more computing power we have, you can compare it to wholesale, right? So let's say maybe Netflix would be a good example. Netflix, like before they started to as a VOD platform, they were just selling DVDs, right? And probably they were selling DVDs back then on the same price. Price of one DVD was the same as the price of the entire month of subscription for like thousands of movies which they have. And why is that? Because of the wholesale. I mean, if you are selling DVD, you have to physically, record it, you have to print it, you have to do a lot of work to, physically to make it done. But if you are just having a platform as a Netflix, you're using the scale of wholesale, and you're just making sure that the platform is working, and you don't have to think about every single user, because every single user should have the same experience. Also, the other reason is because every single day we have much more computing power, not computing power, but network capabilities, right? The network bound rate every single day they are bigger, right? Like 10 years ago, probably you had like 1,000, slower internet, or 100 than nowadays, right? And you paid the same price for 100 times, slower internet than you're paying right now. So if you combine it together, this is the reason.
Okay, true. And then we talk about the technologies, we talk about the threats that come with not being able, to secure all the data all the time. And then how about we talk about, adapting those technologies for your company? Like those three, I think the major companies, they are already using IoT devices, they are already using cloud computing, and AI for sure, or they will be using AI in the nearest future. How do you approach implementation of those different technologies for like not for our day-to-day lives, but for companies that probably have a more difficult job to do than just as people?
Yeah, I would say no matter what kind of business you have, if you hire some people, you can be beneficial from all of those technologies. Let's make some examples. So first of all, let's say we take IoT devices. If you just buy some IoT devices and put it in your office, it will measure you exactly, for example, how much electricity you use, and it will help you to cut the electricity, for example, when no one is at the office and someone just forgot to cut it out. It could be like hundreds or even $1,000 per month if you are just from savings from that. If you consider cloud computing, think about how you usually communicate with each other. I mean, do you like let's say you're writing some document, you want to send it to everyone. You can do it like with email or whatever you want, but also you can use cloud to share the same file with everyone and just tell them, okay, now you have the new file in this cloud. So you're sure that everyone are editing the same document, and there's like less probability that, let's say, someone will change it on his local computer and this change will be not adopted to everyone. Cloud will help you with that, and it's very easy to do it because we have, for example, tools from Google are for free and they're use cloud, right? And the third one, artificial intelligence. I think we talk about ChatGPT over here, which is free from the 3.05 version, and from 4.0 it's paid, but I don't think it's a significant amount for the capabilities which they give you. But nowadays you have thousands of different software as a service solutions which you can just buy for a few bucks a month, and you can just outsource a lot of things going on. So I think the only problem is the change management, so the way people understand that a lot of people from an organization can be beneficial from it. And the second one will be our education, to just know what to use and how to use it. So
okie dokie. So any takeaways? I mean, the whole episode was pretty much your takeaway.
Yeah.
So maybe one from me to sum it up.
Yeah.
I would say that we should. All those technologies are available, and we know this, but maybe we should do some more work, in terms of finding new areas that we can implement them. And then constantly running like pilots, right? And just projects that are not super expensive, they kind of simple, but constantly, implement those new technologies in different areas, but make it agile. Just do small steps and learn from it. And if that works and then provides you with the highest ROI, then do more of it. So just constantly identifying different options for using technology in your company, and running pilots that can verify that hypothesis. I think that's my takeaway from today's episode.
Perfect.
And then again, if you like or dislike this content, please let us know, comment, or maybe there's anything more specific that you like us to talk about. Please let us know in the comments. We'll be happy to actually get to know your opinion of what we do here. So thank you, Adrian. Thank you, everyone that listened, and we'll see you next week.
Thank you. Bye.
Thank you. Bye.